All right, let's begin. Welcome to lecture 9. Today we're going to be talking about exam 1. Specifically, we're going to try to do some review problems. Some of you might find this helpful. Some of you might find this stressful. Let's go right into it. So we're going to start with some grading updates. I'll talk about those briefly, and then we'll review quiz 2. So it turns out that quiz 2, I think a lot of people had a hard time with it. It's our runtime quiz on trying to find the runtime of functions on Big O and stuff like that. So we'll spend the first part of the lecture going through that. Then we'll take a break and then dive into exam expectations. And then you'll have 30 minutes to go through a practice exam. I've actually taken the exam from last fall, cut out a bunch of questions, and then designed the form so that it'll be exactly the form that you'll use in the exam on Thursday. So the goal is for us to all take the exam for about 30 minutes and then go over it with the remaining time, right? I know that that can be stressful for some of you, as I mentioned before, but this is really meant to just be practice. It's not graded. There's no sort of bad things that happen if you don't do super well on it. It's here to help you figure out what you are needing to practice and to see how you react to the actual quiz our exam format that we'll have, right? So think of this as kind of a mock exam or a dry run so that you can feel more prepared for the real thing. And as I said, at the end, we'll review answers right after. All right, so first things first, let's talk about grading updates. Homework 0 grades are released. I believe all of you should have the grades. Sorry for the delay in homework. So I'll talk a little bit about why that's delayed in a little bit, but essentially homework grades are out for homework 0. You can check out the answers to the questions and the rubric that we used on Piazza. So go ahead and take a look under homework solutions and recovery points. You can see the homework 0 here is displayed so that you can check out what you got right and wrong on homework 0 and what the points of that are like. And you can actually earn points back by doing this homework recovery. So it says on the GitHub repository for your homework, go to the pull request and then answer the following questions. It asks you, hey, what mistakes did you make on the homework? What do you think? Why do you think that happened? As well as what do you think you can do better next time, right? So if you want to earn points back from not only homework 0, but homework 1 and homework 2, you can do that this week. This is meant as a means to review. And for example, I'll show you exactly what I mean. We can go to my GitHub repo for homework 2. You want to click pull requests, and under feedback, you have a comment box here that you can type in your homework corrections here, right? So the goal here is to use this box here, and we'll review your corrections and give you points back in order to do well in the homework. So remember, this course is all about helping you learn. The goal of this course is to help you learn. The staff are here to help you succeed. The homeworks are not meant to penalize you just because you didn't learn something perfectly the first time around. So corrections are meant as a way for you to not only review the homework so that you can be prepared for the exam, but as a way for you to reflect on what you can do to improve in the future. How do we know which exact questions you got wrong? That's a great question. You have to use this rubric here and do your best to self-grade. Right. In the future, we'll have better feedback mechanisms but for now, you're going to have to read the code and compare it to what you wrote and also look at the rubric to give you kind of hints on what to do. If you're completely lost, you can go ahead and make a private post and ask. But for the most part, the expectation for these first 3 homeworks is that you are part of what earns you the points back is for you to understand what you got wrong by trying to figure it out. Right, so we gave you the solutions, you have your submissions, and you should compare the two to understand what happened. So homework corrections are different for each homework. So this is, if I wanted to do homework corrections for homework 2, I would put my corrections for homework 2 here, right? So there's gonna be one for homework 1. So for example, here's my submission for homework 1, right? And so I would have to go and add my corrections for each homework independently. Okay. If you have any other questions, feel free to ask here on this Piazza post. But the goal is by the end of this week that you submit your corrections and we'll update your homework grades accordingly. All right. So other things we care about. Quiz grades are out as well. So quiz 0 and quiz 1 should be all the way graded, except for a few makeups for quiz 1. There's still a handful of you that we haven't put in grades yet. They should be on iCollege, just like in homework 0. And then quiz 2 hopefully should be released tonight. I'm trying my best. It might be tomorrow morning, actually, if I'm being honest. But we're working really hard to catch up on grading. Quiz grades will always be faster. We'll try to keep that up and have a turnaround time of maybe a week at most going forward. Homework grades are going to take a little bit longer just because the homeworks are more involved and there's a lot to do when you're grading homeworks, right? And not only do you have to check for correctness, you have to check for partial credit. And we also have to check for academic integrity, seeing if anyone cut any corners or otherwise violated any of the course policies. Don't we still have a homework this week despite the test? No, the homework actually is not posted. One thing you should do is actually check out the announcements. Every week I'll send out some announcements and an FAQ, and you should definitely read that. This is mandatory reading in order for you to keep track of the course. And the first question is, where's homework 3, which will be released later on. So it'll be released after the exam and it'll be due on the 18th, which is a week from now, right? This is so that you can use the time this week to actually study. And then you don't have to worry about doing this and also a homework at the same time, because I know that it's really busy this week anyways, and there's no point in trying to force you to do like 3 things at once. So the goal here is so that we'll like push homework 3 out for a little bit so that you can focus on studying. You should read everything else here, super important. So if you haven't already, please do. It's basically something you need to do every week in order to keep track of what's going on. I usually tell you everything you need to know here. Other things. Okay, so if you think that there's something wrong on either the quiz or the homework, you can go ahead and make a private post on Piazza. You can see some students have already made posts already. And I haven't had a chance to answer them because I am busy writing your exam and doing all the other things in order to prepare for your exam. But I promise to answer them hopefully by tomorrow or at the end of the week at the very latest. So my goal is to get caught up with everything. Once the exams are hosted, I'll have a lot more time to be able to help you with any questions you have on your homework. But we will answer all of the Piazza posts that haven't been answered already. The private ones on the homework will be addressed this week. Can we do quiz corrections as well, as people are asking? Well, yes, you can. So if you look at the announcements here, there is a way to make up the quiz. You can earn up to 5 points back this week by doing the following. If you ask a question about the exam, a study question about the exam on Piazza, you'll get 0.5 points back. And you can do that up to 4 questions, which is 2 points total. And your questions must not be a duplicate, right? If you want to answer questions on Piazza for a study exam, you can see that there's a lot of posts that have been made, and this is why. You can earn up to 2 points back by answering 2 answers. You won't get any points after answering these. And your answer must be endorsed by an instructor, and you cannot answer your own question, right? Try not to do loopholes here. This is not all or nothing. You can get like 3 out of 5 points back. You don't have to do all of these in order to get all the points. You can get like, 1 out of 5, 2 out of 5, 3 out of 5. And if you show up once to office hours this week, you will actually get 1 more point to close it out. You have to schedule it using the course website as always. And you retroactively, for anyone who's been coming to office hours, we're actually going to give you some additional points because you've been doing everything you should be doing as a student. You will get 1 point per week you went to office hours, right? And if this turns out to be a really good idea, if people are using this effectively, then we'll keep doing it. But for now, let's just try it this week and see what happens. If you have any questions about the mechanics, the details, I think someone asked this here, might help. Actually, let me just go and pin this so that people can find it. But basically, recovery points work like this. So you have essentially like, let's say you took 4 quizzes, that means each one is worth 10 points. And if you have 32 out of 40, for example, originally, then you'll end up with 37 out of 40, right? And if you have 37 out of 40 and you earn 5 recovery points, you'll actually end up with 40 out of 40. But later on, your points can actually be applied to future quizzes. So even if you earn points right now and they don't apply because you've already been doing really well in the quizzes, they apply in the future. Okay, if you have any questions or if you need the details of this, just go on to pin post on Piazza. Should help you out. But essentially, you can see that a lot of people are asking questions and answering questions. And we've been letting students answer them. For the most part, people have been giving really good answers, which has been really exciting to see because I like when students help each other, right? you definitely want to book one-on-one office hours. The group office hours don't count for this because in this case, we want you to actually show up and engage with a TA or me. All right. So I still have some time tomorrow morning if you want to book some time with me. Okay, I don't have that much time, but yeah, if you want to book some time with me, you can, and it'll count even after the exam here, if you want. All right. Yeah, so this only applies for one-on-one office hours, not the group ones. But you should come to the group ones if you're stuck on anything, right? We have group office hours later, right after this lecture. So if you are, working on studying for the exam and you have questions, we're happy to help. Okay. Does anyone else have any questions or concerns? Now's a great time to ask. Otherwise, we're going to move on and talk about something that is super serious, and I have to stare into the camera and really like make this clear about what's going on. So some of you have been taking my questions and posting them on Chegg and getting the answers for them and trying to basically cut corners on the homeworks, right? I can tell I've already seen the questions from this semester being posted. It's really disappointing to see. I really, really, really hate when this sort of thing happens. It really feels bad to see my work used like this and to see that people are cutting corners in this way. And some of you have posted and you've probably got points on homework 0, but I'm here to tell you that later on you will get zeros, because right now we're doing an investigation. We're actually looking into who's been posting these, and we'll find you, because I'm going to work really hard to find the people who are using these solutions, who are asking these questions on Chegg and getting the answers and copying and pasting them into their submissions. And so even if you don't have a 0 right now, even if you have like a reasonable grade right now, you will get a 0 later on this semester. I didn't want to stop and like do the investigation and block everyone from getting their grades right now. So I just released the grades, but I wanted to let you know and give you a heads up that we are actually investigating this. This is going to take a lot of my time. I'm going to lose a lot of sleep on this, but it's going to happen. That's not a threat, though. I'm not here to scare you. The reason why I care so much about this, just like I said at the very first lecture, is that the people who take shortcuts right now, who cut corners or otherwise break the course rules, will be more likely to do that in the future, which is a problem, because if you become a software engineer and you write software for things like airplanes or radiation machines or smog emission software, I don't want you to be the type of person who cut corners in college. I don't want you to be the type of person who is predisposed to cut corners and write bad software, because my friends and family ride in cars and airplanes, and I want them to feel safe. I want them to know that a software engineer did honest work using their own skills and abilities in designing the material and products that we use, right? And so if you did do something that breaks the course rules, and you should go back into the syllabus and double check. Posting on Chegg and asking questions on Chegg, it definitely breaks the course policies. If you send me an email, we can find a way to work together to make it so that the consequences aren't as bad. I will do my best to help you out, because I do want you to succeed in this course. No one who's broken the rules is like permanently a bad student or anything. I'm here to help you learn. Right. So if you felt like you were stressed or pressured, or you had no choice and you had to, cut corners in order to do one of the homeworks, maybe you had to turn it in last minute, or maybe you just feel like you could have gotten away with it, whatever your motivation was, I'm still here, open and ready to help you take the course the right way. If you don't come out and talk to me, I will find you, I will give you a 0. I will do whatever it takes to escalate if needed. And if you get a bunch of 0s and fail the course, well, I gave you a fair warning. Okay. So I'm here to be serious. I'm here to tell you why I care about this. I don't want you to become the type of person who is habitually dishonest in the future. The stakes here matter. It will affect who you are as a person in the future. So if you want to come clean, and you want to tell me that you were being academically dishonest in the past, I will do my best to help you get back on track, and we will do our best to make sure you can still do really well in this class and get a good grade. All right. Okay, so let's go ahead and move on. let's talk about quiz 2. So a lot of people found quiz 2 to be challenging. I think it was the quiz that people, oops, that's not the right thing, that people found I think had the lowest average scores on. I think a lot of people found it, more challenging than the other quizzes, at least based on what I could see. And looking at the grades and looking at the solutions, what students put, it felt really correct to go ahead and try to review this so that everyone feels a little bit better about this runtime stuff, because this quiz was about runtime in Big O. So we're going to go ahead and just review this together, step at a time, for the first half of our lecture here. Okay, so if I were taking this exam, I'd put in my email, or sorry, if I were taking this quiz, why is there an untitled title here? That's weird. I'll put in my name, I'll put in my GSU email, and then I will put in NA here because I didn't work with anyone. We have not yet gotten quiz 2 grades back. My goal is to try to get it in tonight. I might not be able to do that, and it might be tomorrow morning instead. I'm trying my best though. Okay, so let's go ahead and take a look at this. Type purple in chat if you're ready to study quiz 2 together and review it and go over the answers. Cool. All right, so if we look at this, the first thing we're being asked is, given a math function f and a math function g, we say that f is in big O of g. Which of the following are true? All right, and we got a bunch of different options. Now, if we remember what this actually means in practice is that we have a graph here. And this graph has an x-axis and a y-axis like normal. But we're going to plot some function f, let's say in blue, and it looks something like this. And then we have some function g, let's say in yellow, and it looks something like this. Right? The lines don't actually have to be straight. They can be of any sort of shape. But the idea behind f is in O of g. That's how you would say this. F is in big O of g is that f grows no faster than g, right? The rate at which f increases will be upper bound by g. So in other words, g is an upper bound of f. We can also say, using more formal mathematical properties, that f of n is going to be less than or equal to some g of n for all n as n approaches infinity. And we can also go even further and use the formal definition that f of n is going to be less than or equal to some k times g of n for all n as n approaches infinity. Right? In other words, if there is a g, let's say there was a g2 in red here that was smaller than f technically, right? This g2, oops, that's the wrong color. Let's say g2 looks something like this. We could find some constant k and multiply it by g2 so that it becomes like this purple line here and actually is big enough to be bigger than the blue line. In other words, we can multiply g2 by some constant number such that it'll be bigger than the blue line for all values as the values approach infinity, as n approaches infinity, right? Now, a lot of you, I think right now will say stuff like f is smaller than g, or g is bigger than f, or f is faster than g, stuff like this. And the problem here is, don't do this. The problem is that it's not precise enough. Right? What does it mean for f to be smaller than g? F and g are math functions. So what does it mean for one math function to be smaller than another? Likewise, if you say that f is faster than g, are you saying that f grows faster than g? Or are you saying that f is like representing code and that code is faster than g, right? You can see that it doesn't have as much meaning if you use these terms compared to these terms up here. So these terms up here are what you want to be able to understand and say whenever you're talking about this stuff. when you're looking at these examples, they're not precise enough. I could get confused reading and understanding this, right? So you could say that f is underneath g on the graph. That would also be another way to say it, right? In other words, the blue line is underneath the yellow line on the graph, right? That's true. It's less formal. It's less like less normal than what you would normally say here, because it's more like using plain words. But it's at least more accurate as well that the blue line is underneath the yellow line on the graph, which is literally how I think about it when I think about runtime, right? But if you say that f is smaller than g, or f is bigger than g, or f is faster than g, and all the other variants that I've seen in the quiz 2 submissions, you'll not get full points. It will be something where the precision of your statement isn't accurate enough, or it's not close enough. Here we go. Yeah. So could you say that f takes no more steps than g? No, because f and g are math functions. They have nothing to do with code, right? You could say that f of n for some fixed n is going to be less than or equal to g of n, which I think is more accurate, right? So the value of f at some n will be smaller than the value of g for all n approaches infinity. That's accurate. But if we have all of this, then we can go ahead and start interpreting what these answers are and which ones actually we should select, right? So in this case, if we say that g is in omega of f, we know that g is in omega of f is the same thing as saying f is in O of g, because g in omega of f, if you go and review lecture 3 or lecture 4, I believe, you'll know that this is saying that f is a lower bound for g, which is true, right? If g is an upper bound for f, then f must be a lower bound for g. We can check this off, right? This is fine. If we say that g grows no slower, sorry, f grows no slower than g, that's not necessarily true, because if we look at this example, yellow is definitely growing faster than the blue here. And if this is g and this is f, then this second selection must be incorrect, right? All we have to do is find an example, and if it's a counterexample to this statement, then we're good. Lastly, we have f in omega of g, which is saying that g is a lower bound of f, which is literally a synonym. It's exactly what this second one meant. So this is also incorrect, right? So this second one and this third one mean the same thing, right? F grows no slower than g is the same as saying that f is in omega of g, or that g is a lower bound for f. And if we look at this example, if we look at the yellow original g here, the OG, that is going to be on top of f by the definition here, where we said f is in O of g, and therefore we can't select this third one here. Lastly, we have f is a lower bound for g, which is literally, again, this big O translation of the symbols here. So we can check that off as well. Oops. Okay. If you have any questions, you can ask at any time, and I will go over it in more detail. Go ahead and type G in chat if you feel good, question mark if you have questions. All right, nice. Most people are feeling good about this. Actually, I've seen a bunch of G's. Again, I'm always going to try my best to help everyone in the room. So if I see a bunch of question marks, it means that everyone's confused. Even if I see a few question marks, I'll do my best to help you, right? So don't feel afraid just because other people are getting it to ask your question. You can definitely ask, and you shouldn't feel bad just because you don't yet understand something. All right, let's look at number 2. We have f of x is equal to 2x plus 8, and then we also have g of x is equal to 3x to the third. And if we plot this out on a graph, it's going to look something like this. Right? I'm going and plotting it out on the right-hand side here. We know that we have 2x plus 8, so at 8 here, we have some line, which I'll do in purple. And then we also have 3x cubed, which grows really fast, and it'll look probably something like this in orange here. Right, so this is like 3x cubed, roughly. My drawing is not perfect. The curve would be more smooth. And then this is, in this case, 2x plus 8. Right, so this is f, and this is g here. So which of the following is true? Well, we know that the orange line will be greater than the purple line for all values of n as n approaches infinity. There's this part at the beginning that we kind of don't care about, right? This part where the purple line is still bigger than the orange line, but that's not going toward infinity, so we ignore that part. And we can notice here that the orange line is definitely going to be growing faster and being on top of the purple line for all values as n approaches infinity, right? So we can go ahead and definitely say that f is in O of g, because that's what the definition of f is in O of g means. And we can also say that f will be a lower bound for g based on that same logic. Now, if we know that g is going to be growing at this rate, there's no way we could say that g is a lower bound for f, because there's no way we could ever make f grow so fast by multiplying it by some constant number, because that would be what we need in order for it to be the lower bound, right? There's no way we could take some k and multiply it by f such that f would always be greater than or equal to g for all values of n as n approaches infinity, right? This is impossible. This is impossible because of how g is. G is 3x cubed, which is always going to be faster than some linear function. It's going to always grow faster, rather, than some linear function, which means that we know that this one here is incorrect. And we also know that this one here is incorrect because in order for this to be true, this last one, that g is in big theta of x squared, then we know that g has to be in O of x squared, but also that x squared needs to be in O of g. Someone in chat is saying exponential is greater than linear, which is true, but this is not an exponential function. An exponential function is like 2 to the n. This function is actually a polynomial function. So a polynomial function is x to some c. Right? So just as a quick review, linear is like some constant c times n. Someone said, wait, isn't g an upper bound for f? Oh, wait, it is. It totally is. What am I doing? This is incorrect. Someone in chat corrected me. Thank you. There we go. Yeah. It's been, yeah, good catch. Good one. That was definitely my bad, but we saved because people are paying attention in class, which is great. You know, people make mistakes all the time, which is why I don't like just make your homework scores final, right? That's why there are correction points. I make mistakes too sometimes. Linear is c times n, right? So some constant c. Polynomial is n to the c. And then exponential is c to the n. All right. So yeah, for this Q2, all three of these are correct. F is in O of g. G is an upper bound for f, and then f is a lower bound for g. Like all of those things mean roughly the same thing, that we have some function g and some function f, and that g is going to be growing faster than f. In other words, the line here in orange will be always higher or bigger or taller on top of the line here in purple, right? You can see why this precision thing matters, because when you're saying it like that, it can be a little bit confusing what I mean. So this is why I always draw pictures. Okay, so let's move on to question 3. So say we have x, c of x is equal to x to the 4th plus 4. Which of the following are true? So if we look at this, we're asking, is c in omega of x to the 5th? In other words, can x to the 5th be a lower bound for c? And if you draw out the graph, there's no way, right? Like we know that in this case, 4x plus 3 might look something like this. But 5x will actually grow much faster. Sorry, x to the 5th will actually grow much faster. And it'll look something like this. So there's a notable difference. And so there's nothing you could ever do to multiply x to the fourth plus 3 such that it'll be bigger than x to the fifth, because there will be some point at some point that like the green line will overtake the purple line here. All right, so we know that this first one is incorrect, so we can mark that as false. Likewise, if we have x here, which is just the mathematical function f of x equals x, so it's a straight line, straight diagonal in a 45-degree angle, we know that this x will not have the purple line as a lower bound. There's no way. Same problem, that the purple line will grow faster than the blue line here. And so this second one is also not correct. If we keep going, we know that there's an x squared here, which will look something like this in orange, which is going to grow slower than the purple line, but it's going to grow slower at a rate that that c couldn't ever be in the big O of x squared, right? This is saying, can x squared be an upper bound for the purple line, right? If this is x squared and our original f is here, you have to trust me if you don't remember the math for this, but basically there's no amount of buffing of this value that could ever make x squared catch up to x to the fourth as n approaches infinity. There's always going to be a point where the purple line exceeds the orange line, no matter what we use as a constant multiplier for x squared, right? So we again say that this is not correct. And lastly, c is in theta of x to the third. If you remember, theta means that we need to have some value, right? We need to say that c is in O of x to the third, and also that x to the third is in O of c. Someone in the previous class called this a tunnel, because what you'll have is you'll have a value that you can use to multiply the x cubed rather, such that it should be either bigger than c or lower than c for all values as n approaches infinity, and that's impossible. The only thing that you can actually say is in theta of that c is in theta of. So someone asked, wait, is this incorrect? Well, yeah, this is saying that c is a lower bound for x. So there's no way that this purple line can be a lower bound for the blue line here. But let's say for a second that we asked c is in theta of x to the fourth, right? This would be true because we would be able to find some number values. This would be true because we would be able to find some number values that would be able to multiply the x to the fourth so that it can always be underneath the c that we have here. I don't know why I said f all of this time. This should be a c. So the purple line here represents our original function c. Like, let's say we multiplied it by 1, and so we would have x to the fourth here compared to x to the fourth here plus 3. And then in that case, x to the fourth is always going to be smaller than x to the fourth plus 3, right? And then we can also have a line. Let's say that this is 2x to the fourth. And this red line will be always going to be taller than the purple line, which is c, right? So since there's a tunnel, we can have the red line and the green line. We can have both upper and lower bounds for c. And when we're looking at theta of x to the fourth, then this would be true. But this is not, right? There's no way we could take some number like 2, multiply it by x to the third, and then have it be taller than x to the fourth for all values of n as n approaches infinity. Okay, let's go ahead and move on. So in this case, given the following function, what is the runtime? The key here is that we have m is equal to n, we have this for loop, and then we have a while loop on the inside, which tries to make m go down to 0. Once m is down to 0, right? Once it's no longer greater than 0, then we exit out of the while loop, and then we go back to the next iteration of the for loop. Now, the key here was to observe. For I is equal to 0, how many times did the while loop fire? How many iterations were there in the while loop? Go ahead and take 5 seconds. And then after 5 seconds, go ahead and type in chat. What do you think? How many times did the while loop fire when I was equal to 0? Okay, we got some ins, we got some question marks, we got some zeros. If I is equal to 0, then what we'll do, what will happen first is m is equal to n. We'll have for I is equal to 0, I is less than n, I plus plus. So we know that the outer for loop is going to run n times. And the inner for loop, the first iteration of the outer for loop will cause the inner for loop to run n times. What I'm asking, sorry, to be clear, is that how many times does the while loop run for the first iteration of the for loop? For the first iteration of the for loop, the while loop is going to run as many times as there are n in the value, right? So if n is 10, then it'll run 10 times. If it's 100, it'll run 100 times. For the first iteration of the while loop. For the first iteration of the for loop. For I is equal to 0, so the first iteration of the for loop on the outside, how many times did the while loop fire? N times. Now, for I is equal to 1, 2, 3, all the way up to n minus 1, how many times does the while loop fire here? 0, right? Because m is already set to 0 by the time we get to the second iteration of the for loop. And therefore, all of the subsequent calls to this for loop will cause the while loop to not fire at all because m is equal to 0, so we never get into the while loop. Therefore, total number of steps, assuming that everything else is constant work, which it is equal to the n that we have for the for loop plus the n we have for the first time we fire the first for loop, which caused the while loop to run n times, which gives us 2n at the end of the day, which is O of n. Okay? So that's the justification I would expect you to make in order to get full points. You would have to note that the inner while loop runs exactly n times in the first iteration of the for loop. Is there a specific notation for a tight upper bound? Nah, we just use big O. It's fine. Tight upper bound, if you don't remember, means that you are trying to find the number that is closest, or the big O that's closest to representing this, right? Technically, I could still say that mystery is in O of n, right? Everyone understands this, but mystery can also be in O of n squared. This is still technically true, right? This is like saying Andrew is no taller than 10 feet. Of course, I'm no taller than 10 feet, but it's not particularly useful to know that. It's better to say that I am no taller than 5'10", which is my tight bound, right? That's a tight upper bound for my height. How would this change if m constantly updated to n at each iteration of a for loop? Well, if we said m is equal to n inside of the for loop, then we would have like something like n squared. Right, so the question being asked is if we move this to here instead, right? If we took m is equal to n and put it here, then we would have something like a n squared algorithm. Now, lastly, assume we have a function p of n where p is in O of x. Explain why p is in x cubed is also correct. And this is very similar to what I just said. We have x here, right? P will be some function underneath it. So this is like some function underneath it, and we can call this P. I'm going to use a different color because yellow's not showing up super well. Here we go. Right? It doesn't matter what the shape of this is, as long as for all values approaching infinity, that the value of x is always greater than the value of P at that corresponding point. So in this case, we have x. And then we also have 3x, which I'll do in green here, which looks something like this. Sorry, not 3x, but x to the third, x cubed. And so the statement that you need to make is that we know that x is in O of x cubed, right? So x is an upper bound for, sorry, x cubed is an upper bound for x. We also know that p is in O of x, so that x is an upper bound for p. Then it directly follows that p is in O of x to the third, right? In other words, that p is less than or equal to some k times x, which is less than or equal to some big K, just a different K. So I'm going to say big K for now, times x to the third, right? Which implies that p is in O of x to the third on the bottom here. So the logic here is that if x is going to be an upper bound for p, and then x cubed is an upper bound for x, then x cubed is also an upper bound for p. That's all I was expecting you to say here in order to get full points on this question. All right. That's what we have for, can we say that x is in x to the third, or do we also need to say that x is an upper bound of x? These things in parentheses, you need to say one or the other. I really like the words x definition. That's actually, in my mind, the cleanest way to understand it. But if you wrote the statement, like some version of the fact that x is in x to the third, and therefore, since p is equal to x, then p is also in x to the third, you should be good. All right, let's take a 5-minute break. We'll come back at 6:18 and we'll do some more stuff. Would I consider curving the last 3 quizzes? Why would I curve them? You get points back. You can get the answer is no, because you can go ahead and just earn points back by asking questions for the homework. Or not homework, but asking questions to prepare for the exam. So that's like, you know, a way to literally just earn points back that is not reliant on the rest of the class. So that should help a lot. Will we be able to earn points back on the exam? Generally, no, but you still have this survey that you can take. If 85% of you complete the survey on time, which, you know, has already been sent out to you a couple of times now, search for this in your inbox. You should receive 1 point extra credit on exam. If 90% of you fill it out, then 2 points. If 95% of you fill it out, then 3 points. What's the percentage right now? It's like above 70% last time I checked, but I haven't checked recently. Yeah, there's no way to make up an exam because an exam is not the first time you should have seen the material. I gave you the practice exam. I gave you previous quizzes. I gave you the homework. So the exam is really an evaluation after all of those different opportunities to get things and learn them. So in that case, like, it doesn't make sense to kind of redo the exam or anything like that. I've only received the single survey. Yeah, there's only one survey. It should be from Janice Bird, this person. And if you didn't get it, if you search your inbox and you haven't found it, then you can email her and CC me and ask to get another copy. It's the percentage of all classes, not just this specific section. So I expect that like 160 of you need to reply in order to give you like 3 points on the exam. I don't know. The people are saying dang in chat, but the other sections are just as reliable as you all, right? Every section has people who will fill out the exam, the survey, and some people who won't. I trust us more. I mean, that's fair. We're taking a break, by the way. We'll have another 2 minutes and then we'll come back. This cat is adorable. I'm thinking of getting a second cat because I feel like my first cat is a little bit bored most of the time. That's what a dog is for. A dog is a lot of work. I have to go outside and walk it, which I guess would be good for me because, as you might imagine, I don't go outside super a lot right now. Having 2 cats seems right, but it's also going to be a lot more work, I think. Is there a curve on the exam? Will the lowest one be dropped? Generally, no. I might change my mind. Like I said, if I change the grading rubric, it will only help you. But last semester, our like about 75% of the class got an A or a B. So that was pretty good. Like I grade things, the average was like a 3.0, the average GPA. So I didn't need to do anything special in order to like make that happen. It just was based off of the course design. It worked that way. All right. Yeah, the exam is going to be very similar to the practice exam we're about to take, so you'll be able to see exactly what this looks like here. All right, so let's go ahead and talk about exam practice. If you haven't already, read the exam information post, read the weekly announcements. Those are super important. So in this case, it tells you when the exams are. If you can't make it, please email me right away. The earlier you email me, the more happy I will be to accommodate your makeup exam. If you email me like 2 days after the exam, you're going to make me grumpy, and I'll still help you with the makeup, but I'm going to also be like much more strict grading your exam. Not, I'm kidding. I'll be completely fair, but make my life easier, and I will try my best to help you as well. Right. The happier I am, the more likely that the future exams will be fair and good, and everyone will be happy. Right. It's mostly just like I have 160 students, 180 students to keep track of. If everyone emailed me last minute, it would be really stressful for me. So it really helps when you email early. That's really what I'm trying to say. Okay. Instructions on how to take the exam, resources that you're allowed to use and not allowed to use. Again, you're allowed to use the course website. You're allowed to use your old homework submissions and use Replit to write code. You're allowed to use notes. You're allowed to use the textbook. You're allowed to read anything on the Piazza, but you're not allowed to use Google, Quora, Chegg. You're not allowed to use other people or your cat. And you can't use any other resources that I have not explicitly listed here. Any sign of outside help will be an automatic 0, right? As someone who's already just told some of you off for using Chegg, please don't be academically dishonest here, right? It's as much an important part of your education as it is making sure that our society will continue producing decent software in the future. Past quizzes, yeah, it's on. If it's linked on Piazza, it's good, right? You can go ahead and just click through, and that's kosher. All right, study material. That's the most important thing here. You want to be able to review these topics and the practice exam questions and the actual exam questions here. Right, you can use past quizzes if you want. All right, so let's go ahead and take the time to take this exam. We're going to take it together. You're going to spend about 25 minutes answering the questions on this exam. There's 4 questions, so that's really not enough time. The goal here is not for you to like get 100% on this practice exam. The goal is for you to try out the exam format and understand how it's supposed to be done, and to see where you need to practice and study in order for you to do well on the actual exam. So I'm posting right now. You should open up the form and you may begin. You'll have 25 minutes. And then after that, we will go ahead and review. 25 minutes, 30 minutes. Yes, 30 minutes. You have 30 minutes starting now. So everyone should be opening the quiz or the exam, the practice exam. This is not graded. This is not graded at all. This will be worth participation, so you should turn something in. But if you do badly on this exam, no one will know. It will never show up on your grades. This is only here to help you practice and to give you a sense of what an actual exam is like. Yeah, use your GSU email. So, what I would do here is type in my GSU email. On the actual exam, I'll specify more clearly if I need you to type in your GSU email or something else. And then you type in, I pledge on my honor that I have not given or received any unsolicited help, unauthorized assistance on the CSC 4520 exam, right? And then you start answering the questions. All right, so you have about 30 minutes starting now. And then from here, after that, we'll go over all the questions. All right, you may begin. All right, welcome back. So go ahead and turn in your exam if you haven't already. Remember, this is practice. So all I'm asking you to do is turn in what you put down. There is no grading where we won't grade you for your answers. This is only for participation and to help you understand what the exam might be like. Now, I know some of you are really stressed because of how many questions there were or how difficult they were. For difficulty, that's not going to change, but we're definitely going to give you more time on the actual exam, right? You weren't expected to be able to solve every single question in the time that we had. And in the 25 minutes we have to go over the exam, we're not going to be able to go through every single question as well. I'll kind of provide brief overviews of how to solve certain questions instead of actually solving them, right? So how did it go, folks? How do you feel about that? Go ahead and type in chat. Was it hard? Was it easy? Was it somewhere in between? Are you feeling good coming out of it? Some people found it was hard. Some people found it was tricky. No idea what was going on in the first question. It was okay, not bad, needed more time. Needed more time is fair. I'm not here to say that this was a fair exam. This was way shorter than it should have been, right? So don't worry. Our next exam will actually be well calibrated. And I know that you needed more time in order to answer every single question here, right? So now, because we only have about 25 minutes left, we're going to spend the rest of it going over the exam. If you have any questions, feel free to ask. And we will go through every single question as fast or as effectively as possible. Okay, so what the first thing I need to tell everyone is that you're totally allowed to use scratch paper on the exam. You can use scratch paper. You can use your own document if you want to type something out. The goal is for you to write your answers on a separate piece of paper, similar to how we did the quiz, or a separate document, because sometimes your browser will freeze and you'll lose all your answers, and that'll be really stressful. So it's just valuable for you to actually work on a separate scratch piece of paper and then copy and paste your answers in when you're ready. When you're grading coding questions, will it actually be tested or will we check the logic? It'll be a mix of both. Sometimes if we can just understand the logic, we'll give you the points. And then sometimes if it's really complicated or if you like wrote code that we think might work but might have a typo, we might run it against some test cases. Obviously, on the question you saw, you were allowed to use both pseudocode and or Java. Well, pseudocode or Java, not both. So if you write pseudocode, we're going to go ahead and test your code manually by reasoning through the logic. Okay, so let's go ahead and start the first question. The first question here is asking what type of sort is this and what will be the next step in this sorting mechanism, right? So this is a sort we've seen in class, and it turns out that this sort is radix sort. So you need to have watched the last about 10 minutes or so of the last lecture. If you were here during live lecture, this should have been the kind of mind-blowing, exciting moment where I talked a lot about how radix sort can do linear sorting by looking through all of the different elements of the ones place and then putting them into buckets and then reading them out. And then doing that again for the tens place, and then the hundreds place, and then the thousands place in this example, right? So we just finished ones in this demo, and then we go and look at all the elements in the tens place. So we're doing something similar here. And I'll just go ahead and walk through it. Again, if you're not familiar with radix sort, you'll have to double back and watch that video and maybe do a little bit of studying in order to prepare. But in this case, we'll need a bucket for every single element that we see. So 0, 1, 2, 3, 4, 5, 6. Someone asked if I can add more space to the arrays because they're hard to work with. I will try to make it so that it's a little bit more readable so that you can work through it for any array-based problems. But for the most part, I would encourage you to write the question down on your own so that you have your own copy of it, which might help parse it as well. But I'll try my best to make sure that these are readable and not too difficult to parse through. I know sometimes it can be hard to read with all of these numbers in a row. So if we look here, if you have specific concerns about how you want the fonts to be or any other concerns around readability, feel free to send me an email and I'll be happy to work with you to figure out what we can do to accommodate. I am definitely down for making sure that you can actually read the exam. So if things are currently hard to read, we can work out the details in email, right? That goes for anyone watching the video as well. If you have any concerns around like you taking this exam and realizing that you either needed more time, way more time than we were given, or that there's some other set of accommodations that you should have, send me an email. We'll see what we can do. There's some limitations to what I can do right away because you need to have an official letter for some of this stuff, but we can talk it through, okay? But for less elements, I mean, I put in a lot of elements on purpose so that you couldn't just copy and paste it into the demo and run it. So in this case, we are looking, and if we look at all the ones place elements for the very first row, everything that had a 0 on the ones place, so this 10, this 320, this 0 here, this 1330, it came first in the array, the next array here, right? And then the array after that, or sorry, the element right after that is the 31 because it has a 1 in the ones place. And then everything with a 2 in the ones place came in next. So 112, 42, 2 here. And then everything that had a 3 in the ones place came afterwards. That's how you should have noticed. Like that's what you were expected to notice when we were trying to understand this radix sort. Now, in order to move on to the next step, then you look at all of the tens place elements in this array, and you try to put them into buckets like we saw in the demo. So if we see this 10, this tens place has a 1 in it, so we put it in the ones bucket. This tens place has a 2 in it, so we put it in the twos bucket. This tens place has a 3 in it. This tens place has a 0 in it, right? Because 0 here means that we have a 0 in the tens place. This 31 goes in bucket 3. This 112 goes in bucket 1. This 42 goes in bucket 2. This 2 has a 0 in the tens place, so it goes in bucket 0. This goes in the sevens bucket, the fives bucket next, the twos bucket for 23, the nines bucket for 3094. And then the zeros bucket for 3004, 3204, threes bucket for 39, and then threes bucket for 32,039. All right. From there, all you have to do is read off the list from top to bottom and left to right. So 0, 2, 3, 2, 0, 4, 10, 1, 12, 3, 20, 23, so on and so forth, right? If I were doing this in an actual exam, I would double check all of my work to make sure there weren't any typos and that I got the ordering perfectly right. But, you know, this should be something that over time, or hopefully you feel comfortable going through the steps for. The actual mechanics might take you a little bit longer, right? So that's what we have for question 1. Again, if you have any questions, feel free to ask. I put in a lot of elements because I wanted you to not be able to just straight up cheat or like use the demo from here to be able to just put in answers because you can create your own arrays here. But at the same time, I will try to be mindful of, you know, both spacing as well as how many elements you actually have to deal with. Okay, moving on. The next thing here is about heaps. And the thing you need to notice here is that we don't know whether or not this is actually a heap. I said that this was a tree, and we had to decide whether or not this was a heap. So you had to remember the definition of a heap, which is in the heaps and heap sorts demo. And for here, you know that the properties of a heap is that if you're talking about a max heap like you are here, every element must have smaller elements as its children. So 100 is the biggest element in this entire heap. underneath it are all elements that are smaller than it, and that holds true recursively. So for 98, for example, all the elements underneath it are smaller. So is this a heap? Yes, it's a max heap. Represent this tree via the array format we saw in class. Well, the array format we saw in class just expected, you saw this in a quiz, expected that the top element is at index 0. The next element on the left of the top element is index 1, index 2, index 3, index 4, index 5, index 6, index 7. So all we are expected to do is just to read off from top to bottom, left to right, and get the elements in order like this. And you can just put that directly into this answer here. Then we're asked to put 99 into this heap, figure out where we inserted the 99 originally, what swaps take place, and which index the 99 ends up at. So if we were working on this, we add in this case, a 99, right, to the next available spot. So the next available spot is actually going to be to the right of this 40. So this would be, I think, index 9. 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, index 8, my bad. And this is just how we start when we add an element. Now, this will change pretty quickly because we'll try to decide whether or not this is in the right place. 99 is a pretty big number, so it needs to swap upwards. It needs to bubble up if it is larger than its parent element. So in this case, 40 is definitely larger than 99. So we're going to go ahead and put the 99 where the 40 used to be and put the 40 where the 99 used to be. Right? And we do this, complete this swap here. Then we ask the same question one more time. Is 99 bigger than its current parent, which is 59? It is. So we're going to go ahead and move it one more time up here and say that, okay, well, 56 needs to go back to where the 99 used to be because, you know, the 56 position should be occupied by 99. So in this case, 56 goes where 99 used to be, and we swap one more time. So in summary, we inserted 99 to the right of 56. Sorry, to the right of 40, the original 40 here. Swapped with 40, swapped with 56, ended up at index 2, right? Sorry, index 1, because this is index 0, then this is index 1. So this is what I would put, something like that, and we could put it here. Right. You could add a little bit more detail. You can say swapped 99 with 40 and swap 99 with 56. And then you can also put that this was index 8 in order to be like getting the complete and correct answer here. Okay. If you have any questions, feel free to ask. Otherwise, type heap if you're ready to move on. Question mark if you have some question, heap if you're ready to move on. Right. This one should be relatively straightforward. If you think about it, the level of Bloom's taxonomy I'm asking you to do is apply. In fact, about 50% of the exam will be apply, and then 50% of the exam will be analyze, evaluate, and create. And that's on purpose. So most of what you'll be learning you can get at least half of the exam questions if you know how to apply what you've learned from class. And then the other half will be, you know, asking you to demonstrate deeper learning in analyzing some questions, evaluating some questions, and then creating some questions. All right, moving on. This is the one that might be a little bit tricky. So we have this function called mystery. In fact, there's a function and a helper function. Right? So the first thing you need to observe number one, this is a recursive function. You can tell that this is a recursive function with a helper because we have mystery here call into another copy of mystery, which is this private method here. So this is a helper function. If you're not sure how I can create a method with the same name, you have to go back and look at the recursion lecture up here, which I talk about in the video. And oops, one moment. So if we look here, we know that mystery will call this mystery down here, and this mystery will call itself. So there's a recursive call that happens right here. There's a helper function. There is a helper function. 3. We are operating on numbers, right? We have numbers taken in as input and then numbers as output. Someone's asking, is the last question on this practice exam create? Yes, it definitely is. It's create, which means that it also uses evaluate, analyze, and apply, as well as, understand and remember. Literally everything is being used for that last question. Okay, so how do we actually understand this if we're trying to write or to understand what's going on, right? There's a couple of questions down here, but before we even dive into them, let's try to understand what the code is doing. Maybe that will help us answer the questions more effectively. The way to answer this, the way to actually figure this out, is to try a small example. Every time you have a function and you're not sure what it does, try to run the code manually. You could type this into Replit if you have the time, but I can also just trace the code by hand. And so that's what I'm going to do here. Mystery of 10 is going to go and check this assert statement, check if 10 is greater than 1. It is. So we don't crash, we move on, right? If you don't remember assert, you should go and check out, I believe, the second lecture, lecture 2, where I talk about it very briefly. Or you can just Google assert Java and then click on the Geeks for Geeks guide and learn about it. Studying before the exam obviously is fine, but you shouldn't use Google on the actual exam. So do study up beforehand. Everything I asked on the exam, you should have at least seen in class in some form or on the homework in some form. As you can tell, I use questions that are hopefully reminiscent of what you've seen in either lecture or homework. So we got mystery of 10 here. The next thing we're going to do is we're going to call mystery of 10 and 9, right? Because we call it on n and n minus 1. So then we go into this body here. Well, the first thing we check here is that we check if n is divisible by a. That's what it means here. This is checking to see if n is divisible by the current a. I'll write this in yellow so it's easier to read. Right, so this here is the mod function. In other words, it's taking the remainder. So in remainder a is equal to 0. If that's true, then it's going to be equally, a is going to divide evenly into n, right? So we know that 9 can't divide evenly into 10. So we move on to the recursive call, which calls mystery of 10 and 8. 8's going to have the same problem. It's not going to be divisible evenly into 10. So we're going to keep going. Now we're going to call 10 and 7, 10 and 6. And then when we get to 10 and 5, we finally have an a here that is divisible into 10, right? So if that's the case, then it says return the current element a, which is 5, which gets passed all the way back up, right? So 5 gets returned from mystery of 10 and 5, which gets returned from mystery of 10 and 6, which gets returned from mystery of 10 and 7, and so on, until eventually we return from mystery, the original call to mystery of 10. So what does this actually do? If you think about it carefully, you'll notice that mystery returns the first number, counting down from n minus 1, that divides cleanly into n, right? In other words, mystery finds the largest factor of n that is less than n, right? So if you remember factoring, 5, 2, 1, and 10 are all factors of 10, right? These are all numbers that when you multiply combinations of them together, you end up with 10. So for example, you can multiply 1 and 5, and you would end up with 10. And the largest factor that is not 10 itself is going to be 5, and that's what we outputted here. Okay? So in this case, we have to answer the questions now. We have to first find the 3 key parts of a recursive algorithm. Some of you asked about this in direct message, trying to ask like, what is the 3 key parts? You're going to have to review the lecture on recursion, because that's definitely something we covered in the yellow slides. Remember, yellow slides are super important. So there's 1 or more base cases, 1 or more recursive calls to a smaller argument, and 1 or more ways to create a solution with the results of the recursive call. So in this case, 1 or more base cases. Well, our base case is when we can divide a evenly into n, right? So that is what our base case is. We'll call that number 1. And then the next part is to make a recursive call on a smaller argument. You can just see that, here we have called mystery on n and a minus 1. And we can say that is our number 2. You would want to type this out down here, obviously, but I'm running short on time, so I'm just going to illustrate. And then lastly, if we want to return the entire thing, that would actually be our number 3, because the solution to this problem is the solution to the smaller problem. Now, on this on the exam solutions, it says in A that it doesn't apply. I'm okay with either answer. You can either say that, oh, there's not really a way where we combine the answers, create a solution with the results of this recursive call, because we're not really manipulating the results. Or you can say, well, we just return the results of the smaller call, and that in itself is our solution. Either way, that's fine. But those are the 3 parts. All right. If you have any questions, please ask. Okay, moving on. Right. Ask now, and I'll be sure to answer before we move on to the next question. But the next question we have is this a divide and conquer algorithm? Why or why not? Well, if you remember, there are 2 things we care about if we need to identify a divide and conquer algorithm. I'll just write them out, but you should check the divide and conquer algorithm lecture in order to learn more about it. Divide and conquer needs 2 things. 1, 2 or more recursive calls. 2, each recursive call must make the argument, must reduce the argument by some multiplicative factor, right? So we take a problem and we make it smaller by 1/3 or 1/2 or 1/10. Someone asked, what is an example of an algorithm with the 3rd part of recursion? That's a great question. There are some examples in the lecture here. For example, when we're standing in line, if you add 1 to the number of the person in front of you, that is creating a solution given the solution from the smaller problem. There are more examples in the slides, and you can check them out and ask on Piazza for recovery points on the quiz, right? So these are great questions to ask on Piazza, and we'll be happy to help you out. Well, in this case, if we look at the divide and conquer algorithm, going back to that, there are not more than 1 recursive call here. There's actually exactly 1 recursive call. This original call to mystery doesn't count, right? This is just calling into the helper function, which is actually properly recursive. So that doesn't work. And also, we're making the problem smaller by 1 at a time, not by 1/2 or anything like that. So we know that this is also not divide and conquer because of that, right? So divide and conquer here, it's not. So no, because we only have 1 recursive call instead of 2 or more. And the problem is being reduced by 1 each time instead of by a multiplicative factor, right? Imagine I could spell. Okay. Lastly, it's asking, what are the types of inputs that would result in the least number of recursive calls? Well, if you're thinking about how mystery is returning the largest factor, the largest factor is always going to be whatever you divide that number by 2 with, if it's even. So what we care about here is all even numbers, right? Any number that's even will make n over 2 recursive calls. Because if you look at the example for 5, we go from 5 all the way down, 10. If we look at 10, we go from 10 all the way down to 5, and that's 5 recursive calls. That'll hold true for any even number. And if you think carefully about factors, the only factors that you have, the first largest factor you'll have will always be half of your number if that number is an even number. There aren't any other larger factors than that. So you would want to write an example here. So for example, I'd include this mystery of 10. And then our description should not fix the size of the number. I didn't say anything about how big our number should be. I just said that it has to be even. So this all checks out. In order to fill this out completely, I would have to type in mystery of 10 and how it made 5 recursive calls. Likewise, following the same logic, what sort of input would cause the most number of recursive calls? All prime numbers will make roughly n recursive calls, right? Because if you think about, for example, the number 7, the only thing that divides evenly into the number 7 is 7 itself and 1, which means we'll have to go from 7 all the way down to 1, which is roughly n recursive calls. Prime numbers are the worst. Odd numbers are not as bad. You would have gotten some points off if you mentioned odd, because that would be like the next obvious thing, but prime would actually be the correct answer in this case. What does this algorithm do? I already mentioned it finds the largest factor of n that is less than it. All right, we're a little bit short on time, but I do want to go and briefly talk about the last question. I know that a lot of you were stumped on it. And this is a question that is actually quite challenging. This question is all about understanding and remembering counting sort. If you see here, we have a bunch of integers being passed in, and what we want is to count up the number of times each number occurs and keep track of it in some sort of counter form. So I'm going to create, in this case, a set of counters from -8, because there's 8 elements in here, all the way up to +8. I'm going to try to do this very quickly, but I'm not going to be able to do this as quickly as I want. I'm going to ask for like a couple of minutes here because we need this in the takeaways, and then we'll be done for today. There's also office hours today if you want to continue asking questions. And obviously, we will also post the answers and the video for this very shortly. Right, so we are typing in counters for everything here. Let's just imagine that I went all the way up to 8 so that we don't have to type everything here. And we're using the second example here. If we look from left to right, the code should look at each element and increment the counter accordingly. So in this case, -2, the counter for -2 goes up by 1. The counter for -2 on the second element goes up by another 1, and then another 1. And then 0 goes up by 1, right? Because we see 0 next. And then 4 goes up by 1, goes up by 1 again. And then lastly, we see 3, which goes up by 1. And then we just iterate through all the elements of the counters array that we made and find the corresponding index that has the largest count. So since -2 had the largest count, we return -2, right? So the key idea here, create a counter array that keeps track of how many times we see each element, update the counters by iterating through the original array from left to right, and then go through the counters and output the index of the largest count using tie breaking by largest index. Tie breaking by largest index because we said here that if there's a tie, return the largest integer. Right? This runs in O of n time because if you create a counter array, that's going to be O of 1. But if you update the counter array, that's going to go O of n because you have to look through every single element and there are n elements. If you use the hash map, that would be fine too. Going through the counters and outputting the index of the largest count will be 2n because if the array is going to be -8 to +8, that's twice the size of the original elements, the original array, which is still O of n. So all of that ends up with an O of n algorithm, right? I'm going to go ahead and pause here and talk a little bit about how this class is designed. In order to get an A in this class, you need to average around an 84% in order to get an A. All the exams, you need an average around an 84%. In order to get a B in this class, you need around a 70%. So you don't have to get an A on the exam in order to get an A in the class. You need to get like a low A to get an A+. Like I mentioned before, about 70%, 75% of the class got A's or B's last semester. So if you felt really stressed about this class, like take a deep breath. This exam is not the end all be all. You can do average or even poorly on this exam by your standards. By, even if you got like, a C on this exam, you're headed probably towards some sort of B. You need to get a B on this exam in order to get some sort of A. And that's all on purpose, right? The exam is designed such that if you got 100% on this exam, you should be TAing this class. You should be a TA and help teach this class. Last semester, a lot of people got A's and A+, but no one got a full score on any of my exams, right? I wanted to see how far I could push the students, so some of the questions were rather challenging. But I promise that I'm grading fairly and that you can still get really good grades on this class and that it's a reasonable expectation. So try not to panic around that. Lastly, in order to really study for this exam, I want to make sure you do 2 steps. The first step is to go ahead and review the material. So I know some of you had some questions on some fundamental things around the slides. You need to go back and watch the lectures and take notes and make sure you understand what's going on. You have to remember and understand first, right? Those parts of the Bloom taxonomy are the core basis for your studying. You need to then review your homeworks and your quizzes, see what you got wrong, see what the staff solutions are like, ask any questions on, stuff you're stuck on. Be sure to use Piazza because then you can get quiz points, recovery points, right? And then step 2 is just the spam practice problems. I gave you a lot of different types of practice. The first practice exam, the fall exam from last semester, which we just did a part of, and then the runtime review. Lastly, again, you can recover homework and quiz points if you just use Piazza and also review your homeworks. Hope that helped. That was the exam review. If you have any questions or concerns, I'm here. The most important thing I want you to take away from this lecture is that the exam is here to assess what you know, but it's not meant to be unfair. And if you don't do super well on it, you can still do super well on the class. We have a lot of different resources to help you out though. So I really hope that you take advantage of them, that you work through these questions, that you ask and read questions and answers on Piazza, and you come to office hours if you can. All right. Thank you so much for your time. That's it for today. We have office hours right now, so you can feel free to stick around and ask more questions, and I will answer anything that you'd like. Thank you, everyone.